Hello everybody. In this video we will learn about graphs of exponential functions. Graphs of exponential functions. So suppose we know how to graph any function by plotting points, right? So now we will see that the graphs of exponential functions have an easy recognizable shape. As soon as you see the graph, you will be able to tell that it is a exponential function. So I will make use of the graphing calculator. So the graphing calculator, in that I will plot, say suppose 3 power x, okay, and you can see that you can see in the graph, like for a small change in the input value, especially in this region, so there is a substantial or a very high increase in y value. So that is how you can recognize that the graph is a exponential function. We refer to terms like exponential growth of anything, exponential growth or exponential increase. So what do you mean by that? Like for a very small interval of input, very small change of input values, you have a high change in the output values. So as soon as you see the graph, you will be able to recognize that this is of a what can I say, this is of a exponential. Yeah, this is an exponential function. So and if I graph another function, that is, if I graph, okay, y is equal to 1 over one over 3, okay, whole power x. Okay, so this isn't working. I'll just clear everything. And we had the graph y is equal to 3 over x, right? So and another graph is y is equal to 1 over 3, okay, 1 over 3x. Okay, see, you can see the green line and the gray line, right? So they are the reflection of each other. So we have obtained, like, y is equal if f of x is equal to 3 power x, we have the gray line, and if f of x is equal to, so this would be f of x is equal to 3 power x, and this would be g of x is equal to 1 over 3 whole power x. Okay, so they both are reflection of each other. So that means g of x is nothing but f of minus x. So g of x is equal to f of minus x. So this figure shows that the graph of family of exponential functions f of x is equal to a power x, like for many values. So if you draw a table of values, so if x is -3, -2, -1, 0, 1, 2 and 3, and f of x is equal to 3 power x, so you have 1 over 27 for the -3, 1 over 9, then 1 over 3, and 1, 3, 9 and 27. And if you plot g of x is equal to 1 over 3 whole power x, you can see the reflection value, that is 27, 9, 3, 1, 1 over 3, 1 over 9 and 1 over 27. Okay, so we can see that the graphs of the family of exponential functions, f of x is equal to a power x, where a takes any value. In this case it is taking the value 3. We can plot the points, and all the points of this graph pass through the point 0 comma 1, because a power 0, if f of x is some a power x, so a power 0 is 1. So because a is not equal to 0, right? And you can see that the graph here, it is passing through the point 0 comma 1, which is nothing but the intersection point. So this point is 0 comma 1, correct? So any exponential function will definitely pass through that particular point. Okay, so if we plot more points, so if we plot more functions, you can see how the functions looks like there are two kinds of exponential functions. We will see that now. If y is equal to 3 power x was one function, and y is equal to 10 power x is another function. Okay, 10 power x. Okay, and y is equal to 5 power x. Okay, so and y is equal to 2 power x. Okay, so let us plot the opposites of the function. That is, y is equal to 1 divided by 3 power x. Okay, and y is equal to 1 divided by 10, okay, power, okay, yeah, power x. And then y is equal to what else did we do? 1 divided by 5 power x. Okay, so you can see the this colorful picture here. So how the graphs look like. So there are two kinds of exponential functions. One, if a is in between 0 and 1, the exponential function decreases rapidly. That is, if a is, say, 1 over 10, 1 over 5, and 1 over 3, they are all in between 0 and 1. They are the reflections of the graphs that are on the right side of the y-axis. So then the exponential function is decreasing rapidly. And if a is greater than 1, the exponential function increases rapidly. So this figure actually explains whatever I said now. So we have two kinds of exponential functions, two kinds. If a belongs to open interval 0 comma 1, or 0 is less than a is less than 1, then f of x is equal to a power x will decrease rapidly. Okay, and if a is greater than 1, then f of x is equal to a power x will increase rapidly. Okay, so with this we can summarize the graphs of exponential function as follows. So the exponential function, to summarize or to define the exponential function or f of x is equal to a power x, where a is greater than 0 and a is not equal to 1, okay, has the domain. So what was the domain of the function that we plotted? So you can see all the functions here. So the domain is all of x values, like positive x as well as negative x values. Therefore the domain will be R, that has domain R, correct, and range. Let us see what are the values that it is acquiring in the y-axis. So y-axis values are, okay, yeah, y-axis values are only on the positive side of the y-axis. Therefore it is taking 0 also as a value, because you can see there are some lines that are exactly touching, or that are on the x-axis itself. So it is, y value is taking 0 as a value, as well as it is only on the positive side of the y-axis. That is, it is taking values only in the first coordinate and the second coordinate. Therefore the range will be open interval 0 comma infinity. Okay, so the line y is equal to 0, that is the x-axis, y is equal to 0, that is the x-axis, is nothing but the horizontal asymptote, is the horizontal asymptote. Okay, and the graph of f has one of the following shapes. Which is the shape? So it can be either on the, what is that, it can decrease rapidly or increase rapidly. So if it is increasing rapidly, it will be on the, from second coordinate to first coordinate, it will increase in the first coordinate very rapidly. And if it is decreasing, it will be from the second coordinate to, sorry, yeah, it decreases from the second coordinate to the first coordinate. So we will see how does it look like. Yeah, we can go back to the graph. Yeah, so there are two kinds, there are two shapes as the definition says. One is this shape, okay, this shape, and the other is this shape, correct. And this particular shape will be when a is greater than 1, and this shape, sorry, this will be increasing, yeah, and this shape is decreasing, and this will be when a is in between the open interval 0 comma 1, that is 0 less than a and less than 1. So whatever I told now, I summarized it into the thing that is here within the box. We now know how does exponential functions look like, what is the domain, what is the range, and what is the reflection of one exponential function to the other. And we also know the what is the horizontal asymptote, which is the line that acts as a horizontal asymptote of an exponential function. So next, identifying the graphs of exponential function. So like if you are given a graph and you are asked to identify the function, so let us see how can we do that. I will do problem number 22 in the book. Yeah, problem number 22 in the book. So this has a, okay, yeah, the graph looks like this. You have 0 here, and 1, -1, -2, and -3, and 1. Okay, so yeah, fine. The graph should pass through this point and this point, and -3. Okay, so I will draw the graph now. So it is somewhat like this, and this is 1. Okay, and this point that I'm highlighting, or I will highlight it in a different color, green. So that point is -1 comma 1/5. So you are given this graph and you have to find the exponential function f of x is equal to a power x. Okay, so you have 2 points on the graph, as you can see. One is definitely this point is passing through 0, 1. So this is common for every exponential function, correct? The point that I am plotting in blue, this is 0, 1. So it is common for every exponential function. So you cannot depend on that function for your for solving or finding out the function. So we have to depend on this one. This is a special point. So your input, that point says that your x value is -1 and f of x value is 1/5. Okay, so therefore if I write the general form of f of x is equal to a power x, so f of -1 will be nothing but a power -1, correct? So what is f of -1? Sorry, this is f of -1. Okay, so f of -1 is 1/5. That is nothing but a power -1 is 1/a. So comparing the this thing, like cross multiplication, implies that a is equal to 5. Okay, the given function is f of x is equal to 5 power x. Okay, so this is how you identify the functions of exponential functions given a graph. So now we will see how to do the transformations of exponential functions. Before that, I would like to give you the quiz question. No, I'll give you the quiz question at the end of the video. Okay, so now we will see how to apply the transformation of exponential functions. So transformation of exponential functions. Okay, so we use the graph f of x is equal to 2 power x to sketch the graph of the following functions. That is, we use f of x is equal to 2 power x to sketch say g of x is equal to 1 plus 2 power x, and h of x is equal to -2 power x, and k of x is equal to 2 power x minus 1. So for the first one, that is g of x, what is the transformation that is going into it? We start with the original graph, that is f of x is equal to 2 power x, and we shift it upward by 1 unit. So to get the graph g of x, and for h of x, it is nothing but the reflection, correct? We reflect in the x-axis to get the graph what do we reflect? We reflect the function f of x in the x-axis to get the function h of x. And when it comes to k of x, it is nothing but we shift it to the right by 1 unit to get the function k of x. So given any function which has a component of exponential function in it, we can apply transformations as I explained you now, and you know how to apply transformations given a original function, right? Identifying that, you learned it in section 2.6. So you can very well do this using whatever you have learned till now, like use the table of values of f of x is equal to 2 power x and apply the transformations that I told you. You need not calculate the table of values specially for g of x, h of x and k of x. So you just have to do and apply the transformations for the main function, that is f of x is equal to 2 power x. And we have done such problems in section 2.6, I guess. So when we were learning transformation of graphs. And the last part of this video is comparing exponential and power functions. Oops. Okay. So I'm sorry, I think it is continuing to record. Yeah, so comparing exponential and power functions. So let us compare the rates of growth of the exponential function f of x is equal to 2 power x and the power function, f of x is equal to 2 power x and the power function g of x is equal to x square. So let us do that by drawing graphs of both the functions in the following rectangles. So the first rectangle is within the closed interval 0, 3 by 0, 8, and B 0, 6 by 0, 25, and C 0, 20 by 0, 1000. Okay, so let us do that by plotting the graph. Okay, so I will just plot f of x is equal to 2 power x and g of x is equal to x square. Okay, so these are the two functions here, and you can see I will expand it. So the first one was 0, 3 to okay, yeah. So the first function, rectangle was input value is 0, 3 here, and output is so 0, 3 will be here, and output is 0 to 8 somewhere. Okay, here it is 0 to 8. So you can observe the graph there, like how the graph exactly looks like in the shaded region. So here it is. This figure shows that g of x is equal to x square. It does catch up with and become higher than. So your red line, so the colors look alike. Okay, the red line is nothing but g of x is equal to x square. This is g of x is equal to x square, and the orange line is the exponential function f of x is equal to 2 power x. So within that rectangle, that is 0, 3 by 0, 8, we have the function g of x rising above f of x at a particular value, and which is that value? That value is it is here, right? So somewhere here. Okay, so that is nothing but x is equal to 2. Okay, and the same thing you can do with the other two rectangles. There we will see that the graph of f of x is equal to 2 power x will overtake g of x is equal to x square in the second rectangle that is given, that is 0, 6 and 0, 25. So okay, so 0, 6 and yeah, okay, this is turning out to be really messy. Yeah, 0, 6 and 25. Okay, here you can see the orange line is outpassing the red line, correct? So where you have 25 and other stuff, so that means that the function f of x is overtaking g of x in this particular rectangle. Okay, and you can do the same for 0 comma 20 and 1000. So okay, yeah, so let us see what happens in 1000. Okay, so 1000, you can see that the exponential function is like way, you can clearly see separate lines. There was very small gap in between the other two rectangles, that is the first two rectangles that we discussed, but now you can see that the orange line is way far away from the red line. That means, so within the rectangle 0 comma 20 and 0 comma 1000, so you have the exponential line growing very fast than the g of x is equal to x square. So this shows how what is the rate of change, or how fast the exponential function increases or decreases based on the type of the function compared to the power functions. So that is why we say that exponential growth is when it is for something positive, it is very healthy. When it is for something negative, it is really bad. So if you have to if there is an exponential growth of this virus that's going on, so it's really bad. Okay, so let us now I will just give you quiz 4.1.2. okay, so this is problem number okay, just give me some time. Yeah, problem number 46. You can use a graphing calculator to compare the rates of growth of the two functions, that is the power function of 3 power x and the power function x to the power of 4 and the exponential function 3 over x. So that is your problem number 46. And to graph some points and state domain and range of range as well as the asymptote, so I would give you problem number 38. Okay, and to find out the exponential function given a graph, so I'll give you problem number 24. So this is problem number 24, 38, number 46. Okay, yeah, so this is your quiz 4.1.2. So in the next video we will learn about compound interest. So this is essential, like if your bank or any other saving scheme or does offer compound interest, so you will have to know how to calculate your interest amount and things like that. So let us do that. That is very much related to exponential growth of money. So if you are given a very high rate of compound interest, or minimal rate as of savings account interest, if the interest or the money is added on compoundedly to the principal amount that you have invested, so your money grows like within a short period of time. It grows very exponentially. So that is the reason why you will learn about compound interest in this section. So I'll be back with compound interest topic in the next video. Thank you for listening.